You know that feeling, right? Someone explains something to you, and you walk away, somehow even more confused than before. Yeah, we've all been there. So today we're going to pull back the curtain on what makes an explanation truly great. And to do that, we're going to look at how experts teach some of the trickiest concepts in science. All right, let's get into it.
So here's the thing. The heart of the problem is that science, well, it can be super counterintuitive. I mean, our gut feelings about how the world works, a lot of the time, they're just plain wrong. And that is the first big hurdle any good explanation has to get over.
Let's take this question, for example. I mean, it seems simple, right? We all learned this stuff back in school, but take a second and really think about it. Where does a plant's food actually come from? Now, it's a super simple question, but that intuitive answer on the left, that's what a ton of people think. It makes sense, right? We think of food as something you eat, so it feels totally logical that a plant would eat the soil. But the scientific reality is honestly way more amazing. Plants don't just find food, they make it. They literally build themselves out of thin air and sunlight. How cool is that?
And this right here, this is a huge challenge when it comes to learning anything new. See, our brains just love simple, intuitive stories. But science, well, it often tells a more complicated, less obvious story. And that's why the way something is explained is every bit as important as the facts themselves. So, the big question is, how do great teachers and communicators bridge that gap? Well, it turns out they have this sort of secret toolkit, a set of really powerful techniques that are designed specifically to overcome those faulty intuitions we all have. And today, we're going to unpack 3 of the most effective tools from that kit. So, what are they? First, you got to tackle misconceptions head on. Second, you have to find clever ways to show us things we can't actually see. And third, you have to link these huge ideas directly to our world. Okay, so those are the tools in theory. But now, let's see how they actually work in practice. Because this is where a good explanation stops being just a list of facts and starts becoming real, genuine understanding. So, tool number 1. And believe it or not, we've actually already seen this one in action with our plant example. See, by first acknowledging that common intuitive idea that plants eat soil, you're doing more than just correcting a fact. You're actually making space in the listener's mind. You kind of have to gently move that old idea out of the way before the new, correct one has any room to land. All right, let's move on to our second tool. A huge chunk of science deals with stuff that's either way too big, way too small, or just too hidden for us to see with our own eyes. I mean, think about the inside of a single atom, or for that matter, the very center of our own planet. I mean, that's a massive challenge, isn't it? It's not like we can just drill down to the Earth's core and take a peek. So, how on earth do we explain something so huge and so completely invisible? Well, the first way you do it is with a model. And the best way to think about a model is to think of it like a map. A map isn't the city, right? It leaves out tons of details, every single tree, every car, but it gives you the essential structure so you can find your way around. Well, models do the exact same thing for complex ideas. So by breaking the Earth down into just 4 main layers, this impossibly complex system suddenly becomes manageable. It becomes organized. This simple framework lets us visualize what's happening miles and miles beneath our feet. You've got the solid ground, then this flowing mantle, and then the metallic core. All of a sudden, the invisible starts to become visible. Okay, the next technique for making things visible is the analogy. Now, analogies they're such a powerful mental shortcut. They basically build a bridge from something you don't know to a familiar concept you already understand completely. So let's circle back to our plants for a minute. The scientific definition of photosynthesis, look, it's perfectly accurate, but let's be honest, it's a little dense. You've got light energy, chemical energy, carbon dioxide, glucose. It's a lot of jargon to take in at once. So how can we make this whole process feel a little more familiar? You do it by comparing the whole thing to a restaurant. And just like that, instantly, this abstract chemical process gets grounded in something we all get. Sunlight is the energy that's powering the kitchen. Water and CO2 are the ingredients. And chlorophyll, that's the chef, turning all those simple ingredients into a meal. It's just a brilliant, brilliant way to make a complex idea finally click. And that brings us to our final tool, which is all about making knowledge actually matter. Look, an explanation can be 100% accurate, but if you, the listener, don't see how it connects to your own life, that information just isn't going to stick. The best explainers always answer that unspoken question we all have. So what? Why should I care?
Okay, let's take that big idea of plate tectonics. We learned the model, right? The layers of the Earth. But what does that actually mean for us, living up here on the surface? Well, for one thing, it means this. More than 450 active volcanoes are strung all along the Ring of Fire, and that is a direct, incredibly powerful consequence of those massive plates shifting around right under our feet.
And it doesn't stop there. That grand slow-motion dance of the tectonic plates, it's responsible for pretty much all the big stuff. The mightiest mountain ranges on Earth, like the Himalayas, the terrifying shake of earthquakes along faults like the San Andreas, and yeah, those explosive volcanoes. This isn't just some abstract geology lesson. This is the force that literally shapes the world we all live in.
So there you have it. That's our toolkit. But these 3 techniques, tackling misconceptions, making the invisible visible, and connecting it all to our world, they're not just clever little tricks. No, they serve a much, much deeper purpose. See, the real goal of a truly great explanation isn't just to, download facts into your brain. As this quote gets at, it's about sparking something more. It's about creating engagement, about stirring up curiosity, but encouraging you to ask questions. It's really about turning you from a passive listener into an active thinker.
And this is the ultimate secret. The point of a great explanation isn't to close the book on a topic, to just say, okay, you're done. No, it's to get you so interested that you want to open more books, that you want to ask more questions, that you want to start your very own journey of discovery.
So, in the end, a good explanation gives you the answers. But the best ones give you new questions. They arm you with understanding for sure, but more importantly, they ignite your curiosity. So now that you know the secret, what are you curious to understand next?